All right, hey there, Earth Science students. Today we're going to be starting our new unit up, all about geology. And the first thing we're going to be talking about is the structure of the Earth. All right, in order to talk about the structure of the Earth, we got to talk about how the Earth was initially formed. So the Earth was formed 4.6 billion years ago. That's billion with a B, not just million years ago, 4.6 billion years ago. That is a very long time ago. Now, in its earliest stages, it was scattered around the sun in the present-day orbital plane of the Earth. So I want you to think about this picture right here. We've got the sun in the middle, and we have where the Earth is currently orbiting around the sun, but in its place is just a bunch of material, all the stuff that would eventually make up the Earth. So larger particles began to be drawn towards each other by gravity. They were attracted to each other. The pieces then begin to fuse together by this process known as accretion. So think about like one piece sticks to another piece, then a larger piece, and eventually you're going to get one piece that's bigger than everything else around it, and it's going to try and draw in all of the other material that's orbiting around the sun. So at this point, the Earth was still hot. It was mostly molten, which is liquid. It was rock, right? The rock that made up the Earth was mostly just, think about it like lava or magma, liquid rock. It was that hot. So what's going to happen to dense materials in a liquid? Well, they begin to sink. And in this case, they're going to be drawn towards the center of the Earth. So the denser elements, iron, nickel, they're going to sink down towards the center of the Earth. Right? And that's where they are today. We're going to see that the closer we are to the center of the Earth, the more dense our materials are going to be. So less dense stuff is going to float towards the surface, right? It's going to be the outer layers of the Earth. So we're going to see that those layers are going to be less dense than the ones that are closer to the center. So as the planet begins to cool, the surface solidified and the crust began to form. Right? Think about the crust of bread, right? We've got this going around, the interior of the Earth. Think about what we're standing on right now is the crust, right? Is the outermost solid layer of the Earth. But that's not all. We are in the atmosphere right now, right? We're breathing. We're in the atmosphere. So the atmosphere, that formed from the outgassing of gas from the interior of the Earth. And it's mostly going to consist of, at this point, water vapor, carbon dioxide, and ammonia. Notice there's no oxygen in there, except for what's in the water vapor. But there's no oxygen, no free oxygen in this early Earth's atmosphere. It's not a very pleasant atmosphere for what we would want today. All right, so here we got a diagram that's in your reference table. This is on page 10, and this is going to show us what's going on below the surface of the Earth. So I want to drill in a little bit closer to this top portion. So right here we have all of the layers of the Earth listed. Now you may have previously learned about layers of the Earth, and we just basically talked about the crust, the mantle, and the core, right? Well, we're going to get a little bit deeper than that. We're going to go through all these different layers of the Earth. So first, starting out on the outer edge, we have our crust. That's the layer you're currently standing on. That is the outermost solid layer of the Earth. And as we get a little bit closer, as we go a little bit further down, we're going to hit something called the rigid mantle. So that's this next one right here, the lighter line right there, just below the crust. Now, those two layers are divided by something called the MOHO. We don't have to get too far into it, but a geophysicist discovered that when we sent seismic waves through the Earth's through the lithosphere, that they changed at a certain depth, and that was true for most of the planet. So he said this must be where the mantle begins and the crust has ended. So that's going to be our MOHO. Those two layers together, the crust and the rigid mantle, make up what's called the lithosphere. Now they are totally solid layers of the Earth, and they are kind of attached to each other, right? They make up this one layer called the lithosphere. Below that, we have what's called the asthenosphere. So that is also known as the plastic mantle. It is part of the mantle of the Earth. And we call it the plastic mantle because it's not totally solid. It's kind of like taffy-like consistency. You can kind of bend it and move it. It's not fully solid. It's not fully liquid. Deeper than that, we go down to the stiffer mantle. So that's going to be a solid portion of the mantle. And we'll talk about some differences between that and the asthenosphere in a moment. Next, we have our outer core. So this is the first layer of our core, and it is totally liquid. That's something you need to remember about this particular layer. It's going to be entirely liquid. That's different than our inner core, which is going to be totally solid. Now, the reason why the outer core is liquid and the inner core is solid has to do with pressure. Even though the inner core is hotter than the outer core, the amount of pressure that's pushing down on that inner core is going to change it back into a solid from its liquid phase at the outer core. Now, while we're here, let's take a look at density. You can see that as we are going towards the center of the Earth, our density is increasing. So it starts up here, 2.7 at granitic continental crust. That's a type of crust. And it goes all the way down to 13.1 at the inner core. So that's a pretty big difference in density. And it's much denser as we get further down. All right, let's take a look at these two graphs right here. We have our pressure and temperature. So both of these are going to be showing what's happening to the pressure and the temperature as we go through the Earth, as we get closer to the center. If I look at my pressure, you can see that we are going up. We are increasing in pressure as we get to the center of the Earth. Now that makes sense. All the pressure of all the overlying rock and material is going to cause that increase in pressure. Now temperature also increases as we get closer to the center of the Earth. It gets hotter and hotter and hotter. We've got at the center of the Earth, it's close to almost, it's 6,600 degrees, right? Which is close to the surface of the sun, right? That is insanely hot that we got towards the center of the Earth. Another thing we can look at on this chart right here is I've got a melting point. Now this is telling me the melting point of the particular material that makes up that layer. If my melting point is higher than my interior temperature, that layer is going to be a solid layer. If the melting point is less than the interior temperature, then it's going to be a liquid layer. So you can see that there's really only one totally liquid layer, and that is going to be our outer core. There's this layer over here, this is the asthenosphere, and it's partially melted. Like I said, that's kind of like that taffy-like consistency. We're going to be talking more about the structure of the Earth when we do Dynamic Earth later on in this year, but I wanted to kind of introduce it just to kind of show you, what we're going to be looking at in the future of this unit in geology.